So the city of Houston deploys a lot of technology and devices, and we have a couple of smart city labs in place. And Axis is one of our, not only our vendors, contractors of choice, they're also a trusted partner for our community deployment. And we work very closely with Axis. As you can imagine, you cannot predict or forecast every event that is coming through the city of Houston. And so Axis has always been there for us to help us deploy on the fly, if you will, and create solutions. And I asked Wayne and the other gentleman to come on board because as we move into the cybersecurity space and specifically the IoT space, we want a better understanding of how these products, when they're deployed, can affect your cybersecurity posture. I also work closely with Wayne because he deals with a lot of small businesses, and he's going to be instrumental in helping us as we move cybersecurity throughout the small jurisdictions. So Wayne and Glenn, pleasure having you, and we look forward to your presentation.
Great. Thanks, Jack.
Thanks, Jack. All right, so Wayne, you're driving.
Yep. You pull it up, and we should be here. So hopefully people can see this, I hope. Let me know if somebody can see the presentation. Hopefully.
Looks great to me.
Okay. Well, again, I'm Wayne Dorris. I'm the Business Development Manager for Cybersecurity for the Americas for Axis. Most of my job is to take customer requirements, whether they're small, medium, or enterprise, and help deliver those requirements to our headquarters in Loon for whatever we're going to put with devices. As you know, with Axis Communications, we do physical security, so we do cameras, IP audio equipment, and access control. But this presentation is going to be more about IoT in general. My background is 30-some years in the physical security space, and I've spent about the last 10 years working with cybersecurity, and most of those working with federal and DOD customers. But with that, we also am going to allow Glenn to introduce himself. Onclave, which is one of our partners that we partner with, that has some unique technology that we'll talk about at the end of this and go over that. Go ahead, Glenn.
Wayne, thank you. It's great to be here. We appreciate the opportunity to chat with the audience. Real quick, I'm founder of a company called Onclave Networks, and for the past 5 years, we've been building out a platform to protect the Internet of Things, operational technologies in general, but it's really based on secure communications and improving our network capabilities so that we can turn transport into a better security tool and a better solution for enterprises and for device manufacturers. We've been partnered with Access for a long time. Wayne and his team have been an excellent resource, and we've partnered to produce devices that have a new way to be protected and actually can provide savings to the people who buy this equipment. Wayne's right, we're about to enter into a new age of being overwhelmed. I think tsunami is the right title for this discussion, and as we go through it, we'll do our best to address it. My history is I've worked for many years in the DOD and national security space, and a lot of what we've built is based on technologies and techniques used there to protect our national interests. So you'll see some of that and some of that information throughout the presentation.
Yep, so we'll just level set. This is the agenda that we're going to kind of go over today. We're going to talk about the IoT landscape just in general, give you some facts and figures on that. We're going to talk about creating an IoT cybersecurity profile for your environment. You'll find that this is challenging, that IoT devices aren't like regular laptops, servers, or regular IT assets. So you're going to have to do a little customization, particularly for whatever vertical that your business may be in. We're going to talk about some just basic principles in hardening that you can do on most devices. And we're going to get into secure supply chain because that's going to be a much bigger component, particularly going forward, where you're getting products from, where you're getting chipsets from will be important. And the important thing with IoT is the whole lifecycle management. And I think this is one of the struggles that particularly IoT devices may have. But I think it's a part that it's an important part of your processes that you need to add. And then we'll get into ZeroTrust, and we'll at that point we'll be kind of handling it over to Glen, talking about a ZeroTrust application that they have. But we'll also talk about some alternative topologies that you can use to help contain IoT devices on your network. So quickly, we'll just go into the IoT landscape. Not a surprise that it is overwhelming. This is from a 2020 report. There's 50 billion IoT endpoint devices worldwide. And of course, most everybody works in any or one of these sectors. It even affects us as a consumer. If we do the quick math, we would say at 8 billion people, that's about 6 devices per person on the planet. And as we know, with some of the advents of like 5G and cloud and big data, that we're going to see just even more explosion for the amount of devices that are coming. And hence why we titled this presentation the IoT Tsunami, because that's what's actually going to be happening here. So just to talk a little bit about how we got here, there's always been a push for convergence or converged networks for OT and IoT devices in IT. So if we step back just a little bit, go back into the 1980s and 1990s, the IT guy actually was like, hey, my responsibility is to make sure I got email up, I've got my CRM up, I've got whatever my web facing servers are, infrastructure are there for supporting the business. And then in the late 90s, in the early 2000s, everything was like, oh, hey, we should be leveraging this protocol. So, HVAC systems, IP lighting, signage, and all kinds of other sensors, in process manufacturing. Everything today rides on that same IP infrastructure. And the problem is that all of that kind of ended up under the IT or the security, IT security or cybersecurity to protect, but a lot of these are systems that they really don't know a lot about. All they know is that they're on their network. The other thing is that, particularly in industrial control systems or certain other of these segments where you have sensors, a lot of them are legacy products, and a lot of them don't support common security protocols that we would expect if we had a Windows or a Linux or even a VM application. So some of those can't even support HTTPS, Active Directory, or even identity management services. And when we look at the next 3 points, big data, cloud, and wireless, they kind of all go together in the fact that big data is a push. Industry understands that the more that they know about their environment, the more efficiencies that they can drive. And hence, that's why all of these devices have ended up becoming onto your network. But as you know, the endpoint is made to be small and lightweight, and so they're leveraging the cloud to actually do all of this collection or federation of data, and then that's your access point to be able to look at multiple systems worldwide or regionally or whatever you may have. And then obviously with the wireless and cellular connections, that just help add on to the amount of network that we have. And as we know with 5G, the big promise of 5G is that even more IoT devices are going to be utilizing that method for being on your network, and you'll have to protect from. But one of the key points I want to point on this slide is that most of the time, as an endpoint manufacturer, we are looking to make things smaller. And so for a lot of times in that form factor, you have a smaller CPU than you would on a normal premise device, simple networking protocol, network interface and protocols, small and simple OSs, and it may not even have been thought out, particularly on the consumer side, for, hey, what's the life cycle of if I have to change this firmware or software on this device? Can you even flash it? How do I get updates on that? But at the end of the day, it was minimal hardware and software features because we were sacrificing security for cost and form factor of the device. And that's kind of problem that we've been dealing with all along, but that's kind of the history of where we are now and kind of the legacy of what we have to put up with for now. Glenn, you want to talk to this slide?
Absolutely, thank you. So, by example, what you're looking at here is a chart that actually lays out our Department of Defense's attack surface. And we've broken it into two segments, IT and OT. And when we look at these numbers, there's going to be some surprise. But there's also a couple of points, a couple of takeaways from this that we can't miss. So as you can see, in terms of number of endpoints, the Department of Defense is running 260 times as many OT endpoints as they are IT. There's a long legacy of adding a variety of different operating systems. And so if you look, the number is overwhelming. One of the other considerations when it comes to operational technology is lifecycle. As Wayne said, we're kind of, we've kind of weaned ourselves off having laptops and cell phones for long periods of time. We replace them very frequently, sometimes in under a year. A lot of the equipment that's there is obviously, it's complex, but it can be too difficult and way too expensive to replace. The long and short of this is that when we look at this, by contrast, there's two realizations that we need to walk away with. The first one is, given the number of endpoints and the complexity and diversity and life cycle, how can we ever expect to get caught up and understand those devices well enough to truly protect them? And if they're not going away, that means we need to deal with them today. The second point that's, that we need to absorb here and consider is the networks that are running these devices. Just because they're on the wires and they're talking doesn't necessarily mean they're managed. And if they're not managed, they're not going to be protected. So we manage IT very tightly, but all of this operational technology, all these endpoints, have really put us in a position where over the course of 30 years, we've accumulated a massive inventory. And as we start to look closely at how we manage it, it's going to be impossible to manage in the current IT infrastructure using a current IT architecture that's designed for human communications. So to win this battle, we need to change the game. And
right. And the one thing I would add is that if you're a small or medium business, of course, you're looking at these numbers and they're pretty staggering. The important part to remember is it's the ratio. What you need to run your business and all of these other systems that also attach on the network. You'll be surprised to find that a lot of your other devices will maybe more than what you have on your IT structure.
So this slide, thanks for flipping, Wayne. So this slide really speaks to the point that I ended with in the last slide. We need to take a new approach. And if we look at detection and then the isolation and containment needed to really protect an enterprise, we're talking about data and lives now. Part of the reason we need to change this game is because as hard as we've tried, not just for the past 6 years, but really for the past 25, the number of days that a bad guy has been in the midst of our enterprise hasn't improved. So we're doing the same thing over and over again without any improved results. Some of this, as with COVID, is related to detection. If we could detect everybody in the country today and give them a COVID test, we'd know where the infections were. But the reality is, if we don't couple that with improved isolation and containment, the ability to keep people in their neighborhoods and their homes contained so that we can prevent the spread of a virus, we're not going to do ourselves any good, and we're never going to solve this problem. We'll be here 20 years from now dealing with the same numbers we're looking at on this slide.
So really, what does it mean? These are your IT device, your IoT devices will be on the network. The important thing is we don't want these devices to become tools or attack vectors aimed at disrupting or compromising IT systems. We've seen in many breaches, take the Target breach where they came in on the HVAC system and then cross-breached over to the IT system. It's a very known method. So as an IoT manufacturer, we want to make sure that we just don't become an attack vector and we don't become tools for bad actors to use. And it also means that we have to make sure that the data that the hardware and software generates is safe and unauthorized for access and modification. But the important thing is the last bullet point on this slide is that IoT and OT are not IT, and they're very different, and that you, as a customer, you're going to have to develop some specific baselines for how you handle these devices on your network or how you adopt them onto your network. Really, that's the key takeaways here. So with that, we're going to kind of talk through the quick process of creating a baseline for IoT. A lot of times you'll say, well, let's look at some standards, or what standard can I point to? Really, this is a groundbreaking work in the fact that there are some standards out there. There's no one recognized global standard. Here in the US, I've been on a lot of the NIST IoT cybersecurity baseline calls. The baseline itself is really geared more towards consumer products. They have a federal profile that is for putting IoT devices on federal networks. These are good reference architectures that you can draw from to perhaps start looking at your profile. They'll have some good basis for it. But the point is, there is nothing quickly coming that you'll be able to say, oh, if I follow like an ISO 27001 or something, for example, that it would help me to understand my risk management process for this. IoT is its own separate animal, and it will continue to be so. So one of the things that come across my desk quite frequently is I get these huge, either we have to put a device on a network, and usually almost all of the questions are from the control sets of if I had a Windows application. The important thing in IoT is that most endpoints are not running some version of Windows. Yeah, you will get that if it's up at some kind of server doing a collection point, say like a VMS system, video management system, or some other collection point. You may have some Windows environment there. But most are running ARM architectures on a Linux kernel, and a lot of the same safeguards that you would like to use, like multi-factor authentication, Active Directory, may not be usable or even applicable, single sign-on. So when we look at the endpoint, we're going to have to learn to do, we can still secure it, but you're going to have to make, the takeaway here is, rather than taking what your standard issue network policy is from a Windows implementation or a Linux or even a VMware, you're going to have to create this other profile to say, oh, you're an IoT endpoint. I'm going to hand you this document instead, and we're going to talk about some of the control sets that's going to help you with. So we'll talk a little bit now about IoT hardening. So these are just some good basics. Obviously, I go to point number 2, updating the device first with the latest firmware. Depending on whatever manufacturer or product that you're using, its life cycle from the time it was actually manufactured to a distributor to a store till it finally ends up on your doorstep, more than likely by the time you receive the device, there may be already better firmware or software for it. So I usually like to take that first. Hopefully it'll have signed firmware so that I know that I'm getting authentic firmware from the manufacturer. And then by taking that and defaulting it, then I have lessening my chance of having some other stored parameter if somebody had tampered with the device in between. Setting the master password, depending on the device, it'll have a root account, an admin account. You, of course, want to do that. But what normally doesn't happen is you then set up a client account. Or what would be caused, in our case, like a camera, we would set up just a video account. And I don't want to base that, if I can, if possible, on the root or the admin credentials. I want to set that up as an actual user. This way, if that account gets compromised, I haven't lost my root or admin account. Of course, you're going to configure your network settings, and setting the time and date, of course, are very important. A lot of IoT devices use onboard storage for if they can't connect to the network. And of course, you're going to want to make sure that that device is encrypted encrypting that data so that a bad actor couldn't make bad use of that if they were able to get into it. One of the most minimal things is HTTP digest authentication. At least this way, you are at least encrypting the password. This is a pretty low-level thing. It's an important thing to look at. Even if the device can't support HTTPS, which is, of course, a much better method of using a certificate for encryption, but at least this way, you have some kind of minimal protection with that. And again, this is just to keep from having it so open on the wire that it's easy to sniff, easy to see credentials, and able to get that. One of the highly things that is overlooked, if you look at your IoT devices, they're made to work with their little domains. And in our case, in the physical security domain, if I have a camera and a video management server, I really could just use some IP address filtering and know that if it wasn't one of these workstations that are talking to my endpoint, I don't even really need to be listening to that. Or even if I have a technician or an IT laptop that is going to be made for maintenance, then those are the important things that I just need to put on that list to do that. And then disable unused services. A lot of times devices will have a whole host of services, but the way that you may implement it in your environment, you may only use a fraction of those. So if you're going to do that, just disable whatever else you don't need. You'll be saving yourself from having something else compromised as we go. And then on the more advanced side, most devices will support 802.1x. You'll have to have a lot more infrastructure for that, for obviously a radius server and or switches that can also support that as well. One of the things that's highly overlooked is SNMP monitoring. Obviously in version 1 and 2, it wasn't very secure, but SNMP version 3 is very good. And this would give insight to other IT teams to know what's happening with that device, whether it's on, whether it's off, give you some kind of firmware or software level that you'll know. And then remote system logging. In the event that you had a breach, you're going to be wanting to look at these logs, and if your device has been compromised, you may not be able to get to those logs, but by having remote system logging, you'll be able to find out what actually happened on your network, and that will be key for the forensics team at that time. So I'm just going to briefly move over to talk about secure supply chain. I think this is it's important on our IT side, but it's going to become even more important on the OT and IoT side. One is that if you take our case as a camera manufacturer, there's hundreds of them worldwide. But when you look at manufacturers that actually make their own chipsets and their own software, it's really down to a handful. And a lot of times, particularly with an IoT product, the label that you see on it may not be the actual manufacturer that actually manufactured it. So if you can, to help clean up your supply chain, you would want to, of course, ensure that it's better to go with people that manufacture their own chipsets, their own software for it, because they'll own that whole process. Meaning that if you bought XYZ thermostat and it's actually made, say, by Honeywell, well, if Honeywell makes changes to their chipset and or have ongoing issues with their firmware or software, you may not get that update because you're not thinking that this is a Honeywell thermostat. And that's just an example. That's why if you can at least tie up using manufacturers that manufacture their own chipsets and hardware software, it'll make mapping your supply chain a whole lot easier. And as manufacturer, we're responsible for our own certifications and for the entire life cycle of the product. So one of the things that particularly on point 2, particularly in the medical industry, the FDA is talk about this SBOM, or what's known as a software bill of material. I'll talk about it from the access perspective of that when you use our firmware, we do use some open source packages such as Apache or OpenSSL. But when you buy the product off the data sheet, it's not going to tell you that off the bat. So what regulation is looked at is saying, hey, whether you're a consumer or a purchaser of products, maybe you need to know what other dependencies of this product you're buying, you may need to also monitor those. And then just in typical secure supply chain, you would like to know where a manufacturer sources components from, particularly critical components like chipsets, memory, anything that in the manufacturing process where people could alter or put malware in at the time or put configurations in. And then where do they manufacture? A lot of times this can be tied to your procurement process. For instance, in the federal space, it may have to be TAA or Trade Agreement Act compliant or NDAA, National Defense Authorization Act compliant. And at the end of the day, as a small business, medium business, or even enterprise business, you'll want to implement a vendor risk management program that kind of answers these things so that beyond the fact that these devices or system is going to provide a solution for you, you're going to understand what risks you're actually taking on by bringing this manufacturer onto your network. So with that, we're going to move over to a little bit to the IoT Lifecycle Management. And this is just an example. It wouldn't matter what manufacturer it is. This is an example of our older firmware schedule. But the idea was, as a manufacturer, we released new firmware for our product throughout the year. When you take any device, whether it's IoT, there also will have software or firmware updates. And one of the things we had in the past is that you got new features and you also got cybersecurity fixes, but you had to also move and change these firmwares. And where that didn't sit well was in this highly integrated world where we have integrations between systems and devices. A lot of times, if I change my firmware, it may break an integration somewhere else. So we ended up moving to where a customer has an option. They can move things in the active track to say be able to get features and upgrades. But we had a lot of customers that said, particularly government customers that said, I'm not so much interested in new features and upgrades. I'm interested in stability so that I don't end up with messing up these integrations that I might have. So they wanted a long-term support model in the fact that we would continue to patch for vulnerabilities through the life cycle of the product, regardless if the user wanted to change or update the software, they could stay at that level. This also allowed us as a manufacturer that in our manufacturers for say 5-7 years, when we kind of get to that end of life, one of the main things is to make sure that it gets put on a long-term support track so that we can continue to do vulnerability patches for it even after we've quit selling it or it's no longer supportable from us as from a tech support point of view, but from requirements for being a manufacturer and being ethical, we want to make sure that we do that ongoing for as long as we can. I mean, at some point you get where you can't. It's like stuffing sausage. You can't get enough. You got more sausage than you can get into that casing. So at some point, the device just won't have memory or have the ability to run that. But just keep that in the back of your mind. You want to look at when you're purchasing a device, kind of what the software schedule is for it. And this kind of leads us into setting a schedule of how you'll do updates. That's all based on your environment. Some people may want to do that monthly, some quarterly, but the important thing is that you're getting these updates and closing off having these vulnerabilities that somebody can exploit. Test the plan and then making sure that it gets actually implemented. The other thing is kind of understand what's the difference between a service release and a full release. So, and a lot of times there may be a quick patch in the event that it was either discovered for code that we actually wrote, or it could be, as we talked about, we had a dependency on a open source package and they had a vulnerability, so we have to put that patch into our software, in which case we may do a quick service release as opposed to a so just understand those differences when you're working with your vendors and how they're going to address bug and vulnerability patches, whether that's a service release or a full release. And this gets into on the IT side, of course, they would have a non-production test environment. But as we keep having these integrated systems and all of this dependency, is who's actually going to test that ahead of time before we start rolling out. Particularly with IoT, you can end up having 10,000 cameras on your network. I don't necessarily just want to be rolling those updates out until I know that they've tested and that everything still works. And actually, who owns that testing? Is it you, the end customer? Is it your contractor or your integrator or systems provider for that? Or what we're seeing a big push for, particularly in the medical space, is allowing the manufacturer to push those updates. But still, the end customer is going to want to know, is that update going to upset my system in any form or fashion? So with that, we're going to kind of talk about ZeroTrust a bit. I'll hand this over to Glenn, and we'll talk about some alternate topologies and some ways to secure things if you want to take some different approaches besides trying to control and use these devices in the same way that you would a regular IT, applying all these different security control sets. There are some different methodologies for that. Glenn?
Thanks, Wayne. So yes, before I go into the product, let's talk about ZeroTrust as a concept, because it's a concept. It's not a like security. It's a process. It's a way of life, and it really does center around the word trust. So I will go back and go back into what we started with. I had mentioned the intelligence community and Department of Defense. ZeroTrust was really born, the concept of it was born out of that environment where absolute trust of everything and everybody involved needed to be managed tightly and taken as far as it could be taken. So when we look at if we were to go to NIST and bring up the ZeroTrust framework, you would see that it's broken into components. And I want to point out that ZeroTrust is a goal. It's not a state that we're going to be able to readily achieve. But as a goal, it's going to take us farther down the road in improving our protection and managing our assets and protecting them than any approach in the past. So getting back, when it comes to national security, most people are familiar with the fact that to work in national security, you need a clearance. That clearance usually involves a background check and can involve a polygraph. That's our way of establishing that that individual can be trusted before they enter into the system that we're going to be using. In addition to the individuals, we need to have trusted endpoints, trusted systems running inside of our networks, and then trusted networks. So what we chose to do 5 years ago was to focus on the network itself and improving the trust of the network, and then taking that trust capability and embedding it in endpoint devices so that we could have greater surety that in the construct of a system where we're handling important data or protecting lives and running medical devices, that we could trust everything as much as we possibly could in that process. So we have a platform, and I'll get through this briefly and get to, but to explain where we're coming from, we have a secure communications platform that focuses on the network. We have offerings for operational technology, for remote access, and for mobile access. And the reason why we focus on those is that those areas are things that we can get closer to zero trust than a standard IT environment. If we think about a typical IT environment, it's almost impossible to control everyone's communications because we may be going to an HR server in California 1 minute, the cloud for our email another minute, and at lunchtime ordering socks from Amazon. And so IT really has to start with the concept of everything needs to be accessible and we will close things off as best we can. Zero Trust starts with the idea that we're closed and we're not opening up anything to anyone or to any device unless it's trusted. So that's where our approach comes to this. So if we go to the next slide, Wayne, this is a typical commingled environment. And for the last 25 years, we've continued to add stuff to it with the hopes of being able to view it from a single pane of glass. There's always a lot of push toward converged infrastructure with the idea that that single pane of glass is going to make our lives easier. The reality is, when we look at what we've constructed, and if we go back to the numbers that we showed in the beginning of the presentation, the idea that we can possibly add enough policy or process or learn enough about all the operating systems and endpoint behaviors out there that we can protect all of this stuff that we've added is just taking us to the point where we're kind of lying to ourselves. So a lot of CIOs justifiably and rightfully are looking to simplify their network approach and to flatten areas of the network where they can. Well, that flattening is the same approach that we're taking toward improving and getting toward a zero trust environment for a section. So this would be a picture of a converged infrastructure where we are treating a camera the same way we treat a laptop. If we go to the next slide, if we were to take the segments of our network, the devices and systems that are simpler, for example, a camera talks to a DVR and it talks to a control panel. It's not going to order socks on lunch, so it's much more predictable. If we can take the predictable parts of our network, put them into easier to manage, more flat networks that require less policy, less hands-on, we can move to a more balanced approach to managing our network and improving our security posture. In this architecture, you can see that we have 5 simpler networks that have limited access in terms of the number of people, which means the crossover breaches that Wayne was referring to can be eliminated. So now we can actually keep infections in an HVAC from entering into an accounting system. This not only lets us better apply our human resources and gets the most vulnerable, because we're the weakest link in the chain, but it lets us remove people from the process and improve the overall posture of the enterprise and focus more on the things that are harder to protect. So if we go to the next slide, this is a place where we demonstrated this live. It was one of our first tests. It goes back to national security. We were invited by the Secretary of Defense to test in the National Cyber Range. This is this architecture that they put up for us to be tested, where we implemented our platform, shows you that this is a typical commingled DOD converged infrastructure. Commingled environment, routers, switches, VPNs, SDNs. I will tell you that from a national security perspective, pretty much every piece of technology and tool that we use for IT is considered to be vulnerable. The Department of Defense goes to work under assumed breach every day. But they are much more strict about their secure compartmentalized national security environments, and that's where we started our approach to solving this problem. But in this instance, you can see we have a building to the right with a bunch of legacy equipment, some control systems on the top that are managing those devices in that building. And when we look at that, we think we can take this, if we apply the concept in the last slide, we can simplify the IT manager's job. We can simplify the network configuration, and we can get these 2 network segments closer to zero trust than we can IT if we can restrict egress and access. So our solution focuses on, if we go to the next slide, Wayne, taking and building a hard wall around these network segments that strictly control access and apply different techniques to securing the communications into and out of these environments. I won't go into the details of how we do it, but effectively we've taken and created a totally new network here, a closed network on existing wires. This eases the burden for IT and makes management of this environment simpler and easier to secure than if it was open to the slings and arrows of a converged infrastructure. You'll notice we've even added secure access. And there are benefits to doing this. Just out of simplicity, we can gain savings. Out of improved manageability, we can gain improved performance. So if we go to the next slide, Wayne. The idea here is, and whether you look at our platform to do this or not, I think the approach is sound, and there are tools out there that you can apply in each of these categories. But from a zero trust perspective, we should seek to be more secure, apply a zero trust approach to all of the places and devices to make sure that they are trusted before we connect them and use them. And this speaks to Wayne's supply chain discussion earlier about where did the chips come from? Where did the current copy of the BIOS come from? That's not something a small business could do, but it is something that you could ask your suppliers about and that they can collaborate with you on, because collaboration is one of the cornerstones of solving this problem. The second thing we should look to is to not create more complexity in our environments, but to simplify them. The less policies, the fewer certificates, the fewer components that we need to manage, the better, because frankly, people are the weakest link. And the more we get to manage, humans in the mix are going to make the mistakes. And when that happens, with the utilization of things like botnets by the bad guys, it's pretty hard to fend off 100,000 or 1 million attacks in a day when you have even 10 seconds downtime where you're vulnerable. Finally, we need to look at better ways to apply our resources, both the human resources and the hard dollar costs when it comes to managing the network, because if we can't reduce the costs of managing the network overall, we're not going to be able to spend the money that's required to really focus on better cyber prevention. We, in particular, focus on, again, not just the detection of anomalous behavior, but the isolation and containment once this happens, which is why we are in the secure communications business. We want to provide more discrete control over the communications so that the second you find a problem, you can keep it from spreading across your enterprise. So that was what's behind our entry into the market, how we have our discussions with end customers, and how we collaborate with partners like Access to improve maintenance on devices through secure access, how we improve manageability by limiting egress and access to and from physical security systems and building automation systems, medical devices, and other vulnerable assets. So that's kind of the summary from our end. So next slide. I'll hand it back to you, Wayne.
Sure, for now. Yeah, again, in summary, zero trust, or even if you're not going to employ a full zero trust model, you'll want to deploy firewalls, micro-segmentation around your data where it's important. And it's funny because I get this question a lot from small businesses, in the fact that you have the advantage of being able to map your data now while you're still a smaller organization, and it will be far easier to set up these rules and topologies now that allow you to scale as your business gets bigger. A lot of times in the enterprise space, we've already gone through this explosion and we have to do all of this different containment now. Again, create your own IoT security baseline. I just understand these devices are different, understand what you can do with them, whether it's HTTPS, other protocols that you can use to help secure communications, things like that. You just want to make sure that you kind of create a different document that you're going to give to IoT manufacturers that actually makes sense to them of the things that you want done. Last, know who's going to own and update the patches, whether it's IT or IoT systems, just that's working with the manufacturer and yourself about your schedule and keeping devices up to date. And believe it or not, again, just setting up that account policy, knowing who has your admin account or root accounts, just managing your privileged access policy, your password policy. You would be surprised how many times I go into an environment and for all of the 10,000 cameras on the network, it's the exact same password for all of them. And there are better policies to do that. There's better tools and systems that can help you manage password policies for your environment. And then just keeping the system up to date. And then, of course, secure supply chain, know who and where that you're actually buying from. This is actually Glenn and my contact information. I'm going to skip over now, hopefully, to stop sharing because I can't see the actual slides for comments. And I think we may have some time now to take comments and questions from the audience that we may have. So again, yes, as we see, ZeroTrust is a process. It is a way of life. Need to provide more discrete controls over communications. What do you have to say about that, Glenn?
Yeah, I think that we all need to take a step back, acknowledge the fact that we are already overwhelmed and that we're about to get more overwhelmed. It goes to why we're doing this presentation, right? And, from an enterprise perspective, CIOs, unfortunately, they're doing their absolute best. We enter into every conversation with an enterprise CIO and CISO understanding that their tools are limited and that they are forced to deal with an open architecture first. What we try to focus on is educating them on alternative ways to improve their control over their environment, improve their control over their communications, and implement ZeroTrust wherever they can. I see there's a question here about Nest devices. Do you want me to touch on that one, or do you want to hit on that?
Actually, I think we'll get to the Nest devices, but and like Nada said here, should work with vendors to build security into products, and that's exactly what my job primarily is for Access for the Americas, and that's exactly what we're trying to do. We're adding more and more security into it for trusted platform modules, secure elements. How are we going to be in ZeroTrust, meaning when a device boots up on the network through MUD or Brewski protocols, what other information it can give to the software-defined network to quickly set up an access control list for it. But one of the things I wanted to point it out is that one of the reasons we partnered with Onclave was that we're embedding this technology in our cameras as an ACAP or as another application that you run on it to allow us for customers that are saying, hey, maybe all of this physical security stuff or other stuff that I don't really need to touch every day. Why am I trying to put it and manage it in the same process that I have for the rest of the IoT? And so, those are going forward with that. And I agree, it's super critical. And Glenn can talk more about the work that they've done on the medical device side. You want to highlight on that?
Yeah, well, before we even get to the medical device side, I think that we need to level set. Security is a team sport, right?
Yep.
And because this is a process. So while it's really nice for us, and I'm not defending Wayne because he was kind enough to invite me to this party, but the reality is Wayne and every manufacturer can only be so good and so responsible at what they do. Because when products leave their hands and go into distribution and get installed, there's a responsibility to take what they've built in and utilize it. So the process of security has accountability through the entire life cycle. It starts with the manufacturer building in what they can. It moves to an installer or an integrator, making sure that things are installed correctly and passwords are implemented correctly, and there's a process for protecting that information. Then it moves to the ownership and maintenance of those systems, whether it's the owner of the system, the owner of the IoT, or some third party that might be managing the device after it's been installed, like an HVAC. The reality is, in the end, if everybody's not doing their job, then there is a gap that bad guys can run through. So I see manufacturers today working toward building, and Access is doing an excellent job of working toward building in better security, but more importantly, giving better tools to their suppliers and their enterprises to say, here, if you learn to manage this in a different way, you can significantly improve your posture as an enterprise. So I wanted to get that out because I think we all need to understand that.
Mm-hmm.
You're never going to buy a product, whether it's a Nest product or anything else, that a manufacturer is going to say, put this in and it's going to be safe and you'll never get breached, because there's going to be problems with your home network and your enterprise network,
right,
and the building network and the network that the telco supplies and all of the other stuff. So that's one. In terms of medical devices, Wayne's right. They are of particular concern, not just because they have it's low-hanging fruit for the bad guys. Health insurance companies and providers have all the information they need for identity theft and for ransomware. So that information is going to be the first information they go after. 95% of breaches or identity theft occurs from the breach of a medical device, so or a medical system. So it's a real issue. But there's other issues associated with medical devices, in particular medical networks, because since they are life support systems, the Food and Drug Administration demands in many instances that a manufacturer can actually monitor and help maintain a device after it's been installed. That post-deployment connectivity is an area where we are creating problems for ourselves.
yep,
I mean, frankly, we are opening up our networks without adequately securing the connection for that manufacturer.
yep.
Again, I think CIOs and CISOs are doing the best they can with the tools they have. We're focused on improving those tools, and we have some.
Yeah,
The other,
I was going to say we have another question that's come up. Can we talk more about microsegmentation and what are the important things to consider? So microsegmentation is a process for deploying zero trust. And before you do your segmenting, you have to trace where the important data is in your network. And once you have done that layout of where the important data is, so whether it's in R&D, customer purchase data, transaction data, once you have all these little different parts on your network, you would want to create another micro-segmentation. In other words, another factor that you're going to verify credentials or a user or an identity before getting into those resources. And that's what micro-segmentation is about. Instead of just having, in the old topology, we kind of had this one firewall that the outside of the network was unsecure and the inside was secure. And what we all know between insiders and even the bad guys, one of the reasons when we go back to the slide that talked about the delay in detection, the majority of the time they're using valid credentials on your network. So they appear like they are the person that should be there. So zero trust is about, I don't just have this one firewall or moat that I have to get over to get to the network. So microsegmenting is knowing where all of your important data is from a business perspective of where you as a business, it would be highly catastrophic if this business was compromised or if it was ransomized and the fact it was encrypted, you couldn't get access to it. Those are the things that you're going to want to also do further segmentation and protect that data.
so let me jump in with one comment. So microsegmentation in an IT environment speaks to management, right? So when we talk about managing let's take a medical device, and we can microsegment through VLANs, right? Well, VLANs are okay to manage, so we understand this is going over here and this is going over there, and communications should be separated. But VLAN hopping is a very popular method of moving across a network. So while VLANs are good for management, how well you can implement those VLANs and truly microsegment and control the devices and the device's communications is going to determine your ability to manage security. So the greater and more discrete control you have over a device's ability to roam around the network, the less likely it's going to be to spread an infection. Your detection has to be good, but your response time has to be even better in order to make sure that once something is discovered, you're shutting it down. And there's plenty of examples and instances that start with Target and include, at this point, thousands of hospitals, banks, credit card companies. It's just across the board. The one thing I would urge everyone here to do is as you step back and look at this environment, I will say that, I use this a lot. I think the severity that's associated with the operational technology world and IoT devices in particular it can't be emphasized enough to the people who are listening here or who might hear this. And the example that I frequently use is today, I think it's pretty obvious that almost every hospital in this country has been held ransom.
Yeah, that's true.
For the data, right? Well, the data is important, and the bad guys want the data, and they want to use it for identity theft and credit card theft to fund their operations. Maybe it's a country, maybe it's criminals, whatever that might be. And there's a cost associated with that data that equates to some Bitcoin transfer. And, I think we've seen numbers in the $50,000, $100,000 range. And they put a number on that data, and there's even a number for the value of a record on the dark market, black web, the dark web, whatever you want to call it. I think what everyone needs to do as they walk away from this is think about what's the value of a life? What happens if someone gets control of a factory system or a medical device or a water treatment plant? The implications and the costs are much greater. And the effect of that, because we're all connected to one another, is something that we'll all be affected by. So we all need to do our part.
Yeah, well, we're going to be wrapping up here. Again, if you have any questions, certainly looking at Onclave in a way of cryptographically doing this segmentation is a possibility to look at. But at the end of the day, we're here to help. We have resources, and we're able. I know a lot of this was around national security and on a DOD scale, but the important thing is that we're taking these same processes and technologies and being able to apply those to a small or medium business is possible, and not out of the cost option either. So with that, I think we'll turn it back over to Umesh and Liz to move us along to our next set of presenters.
Thank you
so much, Wayne and Glenn, for providing such great information around IoT, educating our community, and talking about ZeroTrust, talking about the NIST standards, talking about microsegmentations, talking about Nest and Nest and Nest enabled, not NIST, but Nest enabled devices and medical devices, and just where all of this is going and how are we going to end up managing millions and billions of IoT devices. And just so this is and how do we have trusted communication? So you've covered such a lot of ground, and we really do appreciate it. And so thank you very much. And I'm going to start bringing on our next panel. But to our audience, let's give a big thanks to Wayne and to Glenn. Shout out their names in the chat. We're going